Systems of Equations, Lesson 3, Quadratic. So this time we're going to solve a system that involves two quadratic equations. The first step is to rearrange them so that all of our like terms line up. So my x squareds are okay, my x's are okay, my y's are okay, but my numbers are not. I have a number on the left-hand side in equation number 1, and my number part is on the right-hand side in equation 2. So let's just rewrite equation number 1 so that it becomes 3x squared minus x minus y equals positive 2. Now I'm going to subtract equation 1 and equation 2 to get rid of my y terms. I don't want to try and get rid of either my x or my x squared term because then I would still end up with an equation with two variables, an x and a y. So I need to eliminate the y. Subtracting gives me 3x squared. 4x minus a negative x is positive 5x. Negative y minus a negative y is 0. And 4 take away 2 is 2. Bringing the 2 over to the left-hand side, I end up with 3x squared plus 5x minus 2 equals 0. This quadratic equation will factor. I could use the quadratic formula or completing the square. It factors into x plus 2 and 3x minus 1. So this gives me two solutions. The first one comes from x plus 2 being equal to 0, so x can be equal to negative 2. The second one, 3x minus 1 can equal 0, so adding 1 to both sides, 3x equals positive 1, or x equals 1/3. I now need to find the y values that match with each of those. So for x equals negative 2, I find that by substituting back into either equation 1 or equation 2. I'm going to substitute into equation 1, and so I end up with 3 times negative 2 squared minus negative 2 minus y equals 2. So I end up with 3 times 4 plus 2 minus y equals 2. 3 times 4 is 12 plus 2 is 14 minus y equals 2. Subtract 14 from both sides and I get negative y equals negative 12 or y equals positive 12. So this gives me the solution of negative 2, positive 12. I also need to find my y coordinate of the solution where x is 1/3. So again, substituting in, I have 3 times 1/3 squared minus 1/3 minus y equals 2. This becomes 3 times 1 over 9 minus 1/3 minus y equals 2. 3 times 1 over 9 is 3 over 9 or 1/3 minus 1/3 minus y equals 2. 1/3 minus 1/3 is 0, so I end up with negative y equals 2 or y equals positive 2. So my solution is 1/3 and 2. I could verify my solution by substituting both of those solutions back into equation number 2. Okay, last question is a situational question. It says, during a basketball game, Ben completes an impressive alley-oop. From one side of the hoop, his teammate, Luke, lobs a perfect pass toward the basket. Directly across from Luke, Ben jumps up, catches the ball, and tips it into the basket. The path of the ball thrown by Luke can be modeled by the equation d squared minus 2d plus 3h equals 9. Where d is the horizontal distance of the ball from the center of the hoop, and h is the height of the ball. The path of Ben's jump can be modeled by the equation 5d squared minus 10d plus h. Solve the system of equations algebraically. So I'm going to solve by substitution, and I'm going to take this equation and rewrite it so that I have h equals. So rewriting for h equals will give me h equals negative 5d squared plus 10d. I can then substitute that in for h into equation number 2, which is this one here. So substituting it into equation number 2, I end up with d squared minus 2d plus 3. Now instead of h, I have minus 5d squared plus 10d, and then I have equals 9. Simplifying, I end up with d squared minus 2d. I need to distribute this 3 into each of these terms. So minus 15d squared plus 30d equals 9. Combining like terms, d and minus 15d gives me minus 14d squared. Negative 2d and positive 30d is positive 28d. And I'm going to bring my 9 over to this side, so it becomes a minus 9 equals 0. I like to work with positive numbers, so I'm going to multiply everything by negative 1. And I have 14d squared plus 28d, sorry, that should be now minus 28d, plus 9 equals 0. Many ways to solve this. If we use our quadratic formula and substitute in, remember that our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Substituting in there, we would end up with two values. They are decimal values. I will accept decimal values because of the fact that it's a word problem. So we end up with two different values. One where, I guess I don't have d, I just have x. Sorry, I don't have x, I have d. Two values for d. D can be approximately equal to 1.6, or d can be approximately equal to 0.4. We're going to discard our value of 1.6 because he's further away from the basket. We're going to assume that if he's tipping that basketball in, that he is doing it from the closest distance to the basket. So that is the distance that is away. To find what height he is at, we're going to substitute into the formula negative 5d squared plus 10d. And so we end up with our height being negative 5. D is 0.4 squared plus 10 times 0.4. And we have a height then being equal to negative 0.8 plus 4, or a height of 3.2 meters. So this means that our basketball player Ben was, 0.4 meters from the basketball net and was at a height of 3.2 meters when he tipped the basketball in.